We are looking at the situation, which is basically in the sport of lacrosse, a ball is thrown from 7 feet in the air, which seems kind of high, but you do use a lacrosse stick, so you can launch from pretty high here. So it's launched from 7 feet, has an initial vertical velocity of 35 feet per second, and we want to know whether or not it reaches two given heights. Does it reach 30 feet? Does it reach 26 feet? So here's how you figure that out. Well, there's a couple different ways. In the context of what we're studying, we're going to use this equation. H of t, the height given time, is negative 16 t squared plus v sub 0 t plus s sub 0. So these two numbers right here, v sub 0, or they're not numbers yet, but they will be. This stands for the initial vertical. Oh, I got it backwards in my color coding. Shoot, I was trying to make a match. That's the initial vertical velocity. This should be the orange. There we go. And then the height from which it's thrown is this guy. So we can actually just take the numbers that they give us and put them into the equation where they go. This number, by the way, is always negative 16. That is the constant due to gravity. If you're throwing a ball on Earth, the coefficient in front of the t squared is always going to be negative 16, provided we're doing feet per second, and that's the unit we're using. All right, so let's put the numbers in where they go. We got the negative 16 t squared. This is your initial vertical velocity, which is 35, so it's positive. It's getting thrown upwards into the air, 35 feet per second. And then it's launched from 7 feet, so we got a plus 7 right there. So now what we want to know is, does it reach this? So that's your h of t values, right? That's the height. H of t is 30, and we want to know if it's going to work. So what I'll do is I'll just plug 30 in for h of t. Negative 16t squared plus 35t plus 7. So in the context of what we've been doing recently, we have been studying the discriminant, and that's going to tell us if a solution or if a given quadratic has real solutions. So that's the idea that we're going to use here. We're going to set this guy equal to 0 by subtracting 30 from both sides. And again, the 30 came from because they want to know if 30 feet would work. So we're going to put 30 in for the height. This is going to give us an equation now set equal to 0. And we're going to find out, let's see, this is minus 23, if this particular equation with that vertical velocity and the initial height here will reach a height of 30. Does this have real solutions? So the only thing we need to do here is the discriminant, b squared minus 4ac. This is the part of the quadratic formula that will tell you if you have real solutions, if the 30 is going to work here. So we will do our b squared, 35 squared, minus 4 times the a value of negative 16 times the a value of negative 23. Now, really, what we're only interested in here is the sign on this number. Is it positive or is it negative? If it's positive, this works. If it's negative, that means this has a complex solution, which means the ball never hits 30 feet. So let's see, let me smooth this up. We'll be able to see all of it, clear that out. We're going to do 35 squared minus 4 times a negative 16 times a negative 23. All right, we have a negative discriminant. This equals negative 247. So that means there is no real solutions. That means 30 is not going to create a situation that is going to work. We don't have a real answer. So ball does not reach 30 feet. We're going to do that same process now with 26 feet. We're going to plug the 26 in for the height. So we'll get 26 equals negative 16t squared plus 35t, the initial vertical velocity, plus 7, the point where the ball was thrown, the initial height. We'll subtract the 26, giving us an equation now set equal to 0. I don't know why I'm stuck on, I think it's negative 19. 7 minus 26, yeah, negative 19. And we'll follow that same process. We're going to do b squared minus 4ac. So I will do 35 squared minus 4 times negative 16 times negative 19. And in fact, I've already got it in the calculator, so I can just pull it back up and change that negative 23 to a 19. This time I get a positive number. It's 9. This means there is a real solution. There's actually two real solutions. That's because it reaches 26 feet and then it comes back down again. So it'll reach that given height twice. So the ball does reach 26 feet. Ball reaches 26 feet. Okay, so I hope that's helpful. One thing I should mention is that there's kind of another way to solve this. What I'd actually prefer to do here is if we took this equation, let's see, if we did h of t equals negative 16t squared plus, let's do 35t plus 7. What I would probably do is just find my maximum. I would do, let's see, t equals negative 35 over 2a, the opposite of b over 2a. So that's going to be negative 35 divided by negative 32. So about 1.09. We'll just round it, about 1.09. So at about 1.09 seconds, it reaches its height. We want to find out what that height is. 1.09 squared plus 35 times 1.09 plus 7. Type that in and we'll get the exact height. And I'm going to use a little sneaky trick here. I'm just going to use the previous answer. So this will be negative 16 times that previous answer, which is this number, so I don't even have to round it, squared plus 35 times that previous answer. I'm just plugging this number in for the t value, plus 7. And I get about 26.14. 26.14. So that means at my vertex, 1.09 seconds, I'm at 26.14 feet. Right? So this is seconds, this is time. And if I know that's the highest that I go, then I can go back and go, no, it's not reaching 30 feet. The highest it gets is 26.14. It is reaching 26, just barely, but it does make 26 feet. Okay, so that's another way to do it. Hope that's helpful. Message me anytime with questions. By the way, that says second. I'm looking at it now, and it looks like it says C time, seconds and time.